All right, here's a problem from that section 2.4 homework. I believe this is number 9. The original problem, I think, had an equal sign right here, but I manipulated the equation, so I moved it over here to get it in our M and N format. Okay, so when we look at this problem, we notice that we've got functions that have x's and y's together, right? So that's one of our clues that this is not going to be a linear function, and so we've got to use the exact equation method. Now, here's the key to understanding the exact equation method. Remember that there's some function out here that's got x's and y's in it. And we took the partial derivative with respect to x, and that gave us m. We also took the partial derivative of that function with respect to y, and that gives us n. So what we're going to do is, in order to find the answer, right, this thing right here, that function is our answer. So if you just look at this algebraically, we're going to say that the partial of f is equal to m times the partial with respect to x, okay? So how do we get rid of this d? Well, that's an integral, okay? So what we're going to do is, if these are exact equations, we're going to take the integral of this thing right here, but we're going to remember when we do this that y is a constant. Okay, so this is what's coming down the road. We don't know if we can do this yet. We've got to find out, are these equations exact? So in order to find out if these equations are exact, or excuse me, if this equation is exact, I'm going to take m right here, and I'm going to find the partial of m with respect to y. In other words, we're going to take the derivative of this thing right here, but we're going to pretend that x is a constant. So if I take the derivative of a constant, then it gives me 0. If I take the derivative of y cubed, I get 3y squared. Now remember, we're pretending that x is a constant, so this whole thing right here is a constant. And what's the derivative of y squared? Well, that's 2y. Well, the next thing I'm going to do is I'm going to say, okay, well, what's the partial of n with respect to x? In other words, we're going to take the derivative of this thing, except y is going to be a constant. So let's pretend that we're going to take the derivative. Let's just take the derivative of 3x. That gives us 3. In other words, our constant stayed and the x went away. Well, remember that y squared is also a constant. So we should have 3y squared right here. Then when we do the derivative of this one, right, remember y is a constant. So we know that we're going to have a 2y here. Now I've got to take the derivative of cosine, which gives me what? Well, it gives me negative sine x. Now if you notice, over here I've got a positive 3y squared and a negative 3y squared. But remember, in our original problem we have this negative up here. So if I distribute that negative, right, then it's going to change these signs right here, so that now these two things are identical. In other words, we have an exact equation. Okay, so this is indeed an exact equation, and because it's an exact equation, I can continue doing what we laid out right here. Okay, so this is step 1. Okay, and I kind of worked it out of turn because I went ahead and wrote down step 2. Okay, so step 2 is right here. I'm going to work with m just because I want to take the more complicated of the two sides and work with it. So what I'm going to do is I'm going to work with this thing here, and we're going to continue to step 3. In other words, we're going to take the antiderivative of m, and we're going to pretend that y is a constant. So m is this thing, x minus y cubed plus y squared sine x. x minus y cubed plus y squared sine x. Now, it's great that we've got this thing, but we need to remember what it is that we're looking at. Well, this is m. And our goal is to take the antiderivative of this thing with respect to x. In other words, y is a constant, right? Y is a constant. So what is the antiderivative of x? Well, that's an easy one. It's just x squared over 2. Let's just pretend for a second that instead of having y cubed, we've got 4. Well, what is the antiderivative of 4 dx? Well, that would be 4x. Except we don't have 4, we've got y cubed. So the antiderivative of y cubed is going to be y cubed x. Remember, we're thinking of y cubed as though it were a constant. What did I take the derivative of to get sine x? Well, I took the derivative of negative cosine, right? Because there's a positive right here, so it's negative cosine. And my constant just stays in the problem. So if you recall, this integral up here was going to be equal to this function xy. And there's one more thing I got to remember. I've got this plus g of y out there, because instead of saying plus c, we're going to say plus g of y. Now, here's what we really wanted to point to, was that this is the answer to our problem. Okay? It's just not as specific as we need it to be. What we want to know then is, okay, if I take the derivative, the partial derivative of this thing, the partial derivative of f with respect to y, shouldn't that equal n? Well, yeah, that's exactly what we said right up here. The partial of f with respect to y is equal to n. Okay, so let's take this guy right here. And remember, we're gonna do this, but we're gonna let x's be constants. So the derivative of a constant is just 0. Minus 3y squared x. So we could easily write that as minus 3xy squared. Not a big deal. X is a constant, right? So this thing is going to show up again down here, cosine x, and the derivative of y squared is just 2y cosine x plus g prime of y. So that was the little, those were a couple of the things that kind of stuck out to us the other day when we were doing these problems in class. I'm going to take this thing and set it equal to what I have in the original problem for n. So if I look, n is just negative 3xy squared minus 2y cosine x. And this is going to equal negative 3xy squared minus 2y cosine x. What does that imply about g prime of y? Well, those guys cancel, so that tells us that g prime of y is equal to 0. And if I integrate g of y, I get just some constant. Okay. Well, now we've got our problem. Or, excuse me, we have our answer. I can go in to this thing right here and replace g of y with c. My board's kind of acting up a little bit. So the answer to our problem is x squared over 2 minus y cubed x minus y squared cosine x plus some constant. Alrighty, good luck.